But let's, so when you draw the free body diagram, here's what you do. You, part of a system, right? You're looking at a system. You draw the free body diagram for a part. You isolate that part. And you look for these possible forces right here. These forces that we listed. Springs, cables and pulleys, which include ropes, chains, wires, anything that can be under tension. Smooth contact, which in this case, we extended that to support reaction. So from that table, look, see which supports you have. And if you are isolating a part from this table, right, make sure that you put the correct force on your on the body that you're isolating and drawing free body diagram for. And that depends on the type of reaction or support you're removing. And the last one is weight, which you put on the center of gravity. So look for these 4 types. The difference is that in rigid body, the type 3 or smooth contact now is expanded to support reaction. So instead of only one type of force perpendicular to the surface at the point of contact, now you have 4 different types of supports, 5 different types of supports that when you remove them from your structure or you isolate your structure from these, you have to put the correct force instead to compensate for this. All right. Cantilever is very common. You'll see a lot in different structures, especially when you design different engineering systems. All right, let's practice this free body diagram drawing on a couple of examples and see how comfortable we can get with the examples. I'll just put it this way: draw the free body diagram for each system. I'll tell you what it is in each system. This is just a practice with free body diagram. I'll to get comfortable with that before we move on. Figure 6. All right, so again, I'm going to bring it again for some reason. Okay. So what we want to do on this, we want to draw the free body diagram for this beam. And this beam has a mass of, the beam has a mass of let's say 9 kilograms. It's not important. The numbers are not important. Now, draw the free body diagram for this beam. I'm going to draw the free body diagram for this beam. I'm going to isolate the beam right here. I'm going to isolate this structure. Bring it here. Let's try to draw the free body diagram. Let's start with the ones that we know. What forces do I have to put on this? All right. And the beam center of gravity is, because it's a uniform beam, it's not mentioned here. When they say uniform, the uniform, just learn that phrase too. Meaning that the mass is distributed evenly. So the center of gravity or center of mass is exactly in the center of the beam. If it's like 6 meters, center of gravity is here 3 meters. I'll show that the center of gravity. For any uniform bar or beam like this, the center of gravity is the center of mass, or center of mass, we use them interchangeably in this course, is in the center, like 3 meters away from this side. So, what forces do I have for this beam? Out of these possible forces that I listed here.
We have the 1200 newtons coming down.
Yes, exactly. So that's the good one. Start. So 1200. This is the external forces there we should take into account anyway. So there we go. This is 1200 newtons. What else?
You also have fixed support.
I have fixed support, exactly, right? This type of support. So if I isolate this one and take it out, right? I have to take into account two components of a force and a moment. Now, you might ask which direction you put it at this point doesn't matter. Just put it, it has to prevent. So you might think, okay, are we preventing the motion to the right or preventing the motion to the left? Don't worry about that at this point. Just take those forces into account. So we have one in this direction, one in this direction. For the sake of argument, I'm going to take this one upward. I'm going to take this one in this direction. So that would be F in Y direction. Let's just call this F in X direction. And since it's a fixed support, I have to also take into account this moment, right? We said like there are three unknowns here. There are three forces, three components. Two components of force and a moment. So I put the moment also, again, don't be too worried about the direction for now. I'll put the moment in this direction. Maybe I should have used a different color. So now that because I want to specify each of them as a category. So let's put this one this way and this way. So that would be Fy, Fx, and let's put the moment in this direction. Moment at A, point A. It's better maybe we just refer to it because it's connected to the wall at point A. It's better to say Ay as a force and Ax. Right, and this is 3 meters away from this point. 2 meters. Sorry. Okay, what else? Anything else left or we're good? Am I missing something or we're good? We can move on.
We're good.
Sorry, say it again.
I think that's it. No,
I didn't hear what you said, Diego.
I said I think that's all the forces.
Oh, well, almost there. There is one missing, right? I gave you the mass of the beam. So that means we have to take into account the weight. Again, weight is always downward. And I told you it's always applied to center of gravity. So I'll put it right here. Center of gravity I'm given, which basically is uniform. So it's in the center, W. And let's, that would be 9 times 9.81. And that's 3 meters away from that side. Now we're done with the free body diagram. This is the free body diagram of this beam. I isolated the beam and put all the forces on this. Let's look at another example. We're just practicing free body diagram for now. This is a part of a mechanism, right? In some structure. I honestly don't remember what that is. I have to take a look at the source. But it's kind of pedal that is either could be a brake or a gas pedal for some maybe lawn mowing machine or something like that. We want to draw the free body diagram for that foot leveler, right? This one. I want to draw the free body diagram for this. For this. Let me take it out first and do my best to show you what I'm trying to draw the free body diagram for. Right. Simplify it. Let's say we have it this way. I'm doing my best to draw something as close as possible to what it looks like. And then I'm going to do that. I'm going to do that and do this. This is its connected to, it's not really there, but I'm going to add it. So you use what I'm drawing as your reference. It's there. and then we have a spring attached to it, attached here. We have that piston and cylinder, you can think about it, attached to it right there. Or I can think about it as a cable. A cable is better. And that's pretty much it. And the foot leveler, so the foot is applying some force on it. Oops. Well, let's put the force here. So here's what I wanted to draw the free body diagram for. Let's call this force F, some force applied. So I want to draw the free body diagram for the leveler. Let's draw it. Now let's draw the leveler here. I'm making my life difficult. I have to draw this again. I'll do it fast. It's a very ugly shape. All right, this, and then let's do this. Let's use names so we can refer to them. This is point A. This is point, let's call this B. Let's call this point C. And that's pretty much it. Give you dimensions, but let's not make it crowded for now. Let's just draw the free body diagram. So what I'm isolating the leveler, right? Foot leveler. What forces do I have to put there? Like I have F, I'm gonna put F there. That is the obvious one. I'm gonna take that away from you. I can't mention that. All right. What forces do I have if I isolate that leveler? Think about those categories I gave you. Right? Spring, cables, pulleys, ropes, chains, wires, smooth support reaction, weight on center of gravity. I didn't mention any weight here, so forget about weight. What do we have here? There is one obvious.
Cable force.
We have cable force at which point?
C.
C, exactly. We have cable force. There we go. Thank you. And it's in this direction. It's under tension. So T, C. What else? And it's applied at point C. Another obvious one.
There is spring support on point B.
Exactly, Nathaniel. Thank you. That's also spring support at point B. So spring, assuming that it's under tension, if F is downward, it's assuming that it's pulling this. I have this spring, but it's very strong. I can't really pull it. But assuming that it's being pulled, so I'll put the force in this direction. It's trying to pull the leveler back to where it was. So this is B, and this is F is spring. And then the last one, which is the support at point A. Now, the support at point A is a pin support. If you come here, there we go. So this is a type of support that the pin you will see, right? This is a pin support because it's preventing, it can rotate around A, point A here. It can rotate, this leveler can rotate around A, but it cannot move in X or Y direction. So that point is a pin, right? And the pin is preventing this leveler to move in two-dimensional space. Now I can think about it as one force with a given direction, or you can think about it as a force with two components, Fx and Fy. Each component is preventing this leveler from moving in that direction. And at this point, again, don't worry about the direction. Right? So F, let's do this color. I can actually use straight lines. Oh my goodness, sorry guys, I'm almost there. There you go. At this point, I'm just gonna take the Y components upward and X component to the left. I'm not gonna tell you why if you choose the opposite direction for each of them or one of them, I'm not going to stop you. That's fine. Because this hypothetical motion, this force can be negative at the end, meaning that the direction should be flipped. So this is it. This is the free body diagram, and this is point A.